Hi, and welcome to this short content bite introducing you to the idea of degrees of freedoms in a chemical sense. Every atom has 3 degrees of freedom: motion in an up-down, left-right, and forward-back direction, or along the x, y, and z axes in Cartesian coordinates. When combining atoms into molecules, the number of degrees of freedom is preserved. The origin of this axiom is beyond the scope of this course, but this rule is important not only in thermodynamics but also in spectroscopy. When we combine atoms into molecules, we introduce new types of possible movement in the molecule: rotations and vibrations. So every molecule still has 3 translational degrees of freedom, and the number of rotational and vibrational degrees of freedom depends upon the structure of the molecule. For linear molecules, there are 3 translational degrees of freedom, 2 rotational degrees of freedom, and x vibrational degrees of freedom. The rotational degrees of freedom are defined as rotation around 3 orthogonal x, y, and z axes. For linear molecules, rotation around what is defined as the z-axis, there is no difference in the molecule's appearance, and so this isn't providing a degree of freedom. Therefore, for linear molecules, there are only 2 rotational degrees of freedom. Any remaining degrees of freedom are molecular vibrations. Therefore, in a linear molecule, there are 3n-5 vibrational degrees of freedom, because each atom contributes 3 degrees of freedom, and there are 3n total degrees of freedom, where n is the number of atoms in the molecule. 3 are molecular translations, and 2 are rotations. If there are 2 atoms in the molecule, then there is just 1 vibrational degree of freedom. For nonlinear molecules, there are 3 translational degrees of freedom: 3 rotations, because each rotation around x, y, and z looks different, and 3n-6 vibrational degrees of freedom. You will learn about the different types of molecular vibration in later courses. So here, I am just summarising the degrees of freedom in a selection of atoms and molecules. Neon exists as an atom, and so the only degrees of freedom it has are the 3 translational degrees of freedom. Molecular nitrogen has 2 atoms and has to be linear. Consequently, it has 3 translational, 2 rotational, and 1 vibrational degree of freedom. Water and carbon dioxide both have 3 atoms, but water is non-linear and so has 3 translation, 3 rotation, and 3 vibrational degrees of freedom. Carbon dioxide is linear, and so there are 3 translational, 2 rotational, and 3n-5, 4 vibrational degrees of freedom. Again, ammonia and acetylene both have 4 atoms, but again ammonia is nonlinear and has 3 translations, 3 rotations, and 3n-6, which is 6 vibrations, whereas linear acetylene, or ethine, has 3 translations, 2 rotations, and 3n-5, or 7 molecular vibrations. My final example is tetrachloromethane, which has 5 atoms and is nonlinear. It consequently has 3 translational degrees of freedom, 3 rotational degrees of freedom, and 3n-6, or 9 vibrational degrees of freedom. You will need to be able to determine the number of degrees of freedom in molecules for later sections of this course. I hope that this introduction to degrees of freedom has been clear. As always, if you have any questions, please do not hesitate to contact me.